Hello everyone. In today's video, we will be talking about the important Python library, which is NumPy. NumPy is a numerical Python, and it is almost used in every field of science and engineering. It is a universal standard for working with numerical data in Python, and it's at the core of the scientific Python and PyData ecosystems. So the NumPy library contains multidimensional array and matrix data structures. And it also provides ND array, which is a homogeneous n-dimensional array object with methods to efficiently operate on it. And it also contains some of the methods which can efficiently operate on the array which is actually created. So NumPy can be used to perform a wide variety of mathematical operations on array. We'll be having some important functions. So using those functions, we can carry out some mathematical operations on those array. And it also adds powerful data structures to Python that guarantee efficient calculations with arrays and matrices. And it supports an enormous library of high-level mathematical functions that operate on these arrays and matrices. So how do we access NumPy and its functions into our Python code? We can do that using the import statement. So import, as we're going to import NumPy library in our Python code, we have to use import NumPy as NP. So here we are importing NumPy, but here as NP here stands for the alias name of NumPy. So that's why we have written it as import NumPy as NP. So what is the difference between a Python list and a Python array? So NumPy gives you an enormous range of fast and efficient ways how you can actually create the arrays and manipulating the numerical data which is actually present inside them. But this Python list can contain different data types within a single list, and all elements in the NumPy array should be homogeneous. But in list, it can have different data types within a single list. So the mathematical operations that are to be meant to be performed on arrays would be extremely inefficient if the arrays weren't homogeneous. So this is the difference between the Python list and the arrays. So why do we wanted to use NumPy library functions? NumPy arrays are faster and more compact than Python list, and an array consumes less memory and it is convenient to use. And NumPy uses much less memory to store data, and it provides a mechanism of specifying the data types. So this allows the code to be more efficient and optimized. When we use NumPy, the code is further optimized. So that's more efficient to actually use. So now before moving into the NumPy library as such, we can see what is this particular array. So array is the central data structure of the NumPy library. And we know that array is a grid of values and it contains information about the raw data. You can find out information about the raw data, and as well as you can locate an element, and you can also try to interpret that particular element. And it has got a grid of elements that can be indexed in a variety of ways. And the elements in the array are all of the same data type, and it is always referred to as D type in Python. So an array can be indexed by a tuple of non-negative integers, by booleans, by any other array, or by integers. So the rank of the array is the number of dimensions that it contains. So if you wanted to find out the rank of the array, then we have to find out what is the dimension of the array which we have actually created. So the shape of the array is a tuple of integers giving the size of the array along each dimension. So example, if you see here, for example, we are actually creating an array. So we use the function array, and NP is alias name that we have created NumPy. So an NP dot array, and inside the as an input to the array, we can actually give a list or a tuple. Okay, so anything we can actually give. So so this is how you actually try to create an array. So this is one zero-dimensional array which is created, and we can also create a number of other dimensions of array as well. So we can access the elements in the array using the square brackets. So when you're accessing elements, remember that indexing in NumPy starts at 0. So this means that if you are going to access an element, first element in your array, then you will be accessing the element 0 index. Index 0 is what you will be trying to access. So if you wanted to print a of 0, then it will give me the elements which are present in the index 0. So if I'm going to access the first element, then I will have to give the index as 0 to access the elements. Okay, so next we will see how to create a basic array. So to create a NumPy array, we have to use the function. As I told you in the previous slides, we have seen that we have to use the function array function. So import NumPy as NP and a variable a as np dot array of. This is a list that which we have actually given. So if you see, you can visualize your array this way. Okay, so this is a command that which we have given, and here if you see, it's 1, 2, 3, the elements which are actually created in the as an array. The elements are created as the array, and also you can also create an array which are filled with zeros. So np dot zeros, zeros is like a function, zeros of 2 if I give, then it will actually create an array with 2 zeros, as you can see here. If I wanted to create an array filled with ones, then I have a function for that as np dot ones of 2. So this particular 2 here refers to the number of ones that will be created. So there will be 2 ones that will be created in the array. So this is how it will be created in the array. There will be 2 ones which are created. And how do we create a NumPy ND array object? So NumPy is used to work with arrays, as we have seen, and the array object in NumPy is called as ND array. So we can create a NumPy ND array object by using the array function. So we can see here, import NumPy as NP. NP is alias name, and NP dot array. So these are the elements at which we pass as input to the array, and then the array is actually created with all these elements like 1, 2, 3, 4, 5. And when you're trying to type the array, so print type of array if I'm going to give, then it will give me an output as array that is being created. The name of the array that is being created is NumPy dot ND array type. ND actually refers to n-dimensional array type. So that's the type of the array that is actually going to be created. So always when an array is created, then the type of the array that is being created is ND array object. So we can also use a tuple to create a NumPy array. So we can use a list, we can use a tuple, and all this can be given as an input to the array method. So if we can see in this particular example that a tuple has been given as an input to the array method. So you are trying to print the array, then you can see the output that is being created with all these different 5 elements, starting with the index 0 for the array. So next we will see about the dimensions in array. So a dimension in array is one level of the array depthness. Okay, so the nested array is the arrays that have arrays as their elements. So you have 0-dimensional array, we have 1-dimensional array, a 2-dimensional array, and so on. So if I wanted to create a 0-dimensional array with a particular value, here I wanted to create it with a value 42, then I can actually do that. I can directly pass the element inside the array method. So if I'm going to, so using these statements, I can actually do that. NP dot array of 42. I'm actually directly passing for 42 and then trying to print array. So this is a 0-dimensional array that is actually going to be created. Next, we can also create a 1-dimensional array. An array that has 0-dimensional arrays as its element is actually called as unidimensional or 1D array. So, so to create a 1D array containing all these elements, we can actually pass it as a list, and then you can actually print. So this will constitute the 1-dimensional array. I can also create 2-dimensional array. that is often used to represent matrix or a second order tensor. So here, if you see here in this array method, the input that is actually going to be passed is two tuples, or the input that is actually being passed to the array. So this constitutes a two-dimensional array. That means you will have two rows. Okay, so you will have a two-dimensional array that is created. You can also create a three-dimensional array. So to create a three-dimensional array with two 2D arrays, both containing two arrays with the values 1, 2, 3, and 4, 5, 6. So we can actually create it like this. So we are passing four different elements of tuples inside the array method. So the output will be 1, 2, 3 is one row. You will have another row which is 4, 5, 6. The third row will be 1, 2, 3. And then the fourth row again is 4, 5, 6. Okay, so these are all the different dimensions of arrays which we can actually create it through the NumPy package. So in this particular lecture, we have seen the basics of how we can actually create array using a tuple and a list, and also how we can create different dimensions of array, and also how we can know the type of the array that is actually going to be created. Thank you.